In this chapter, we will explain the reference models of the network. Okay, there's many different reference models, and we discuss some of them. And then we will discuss the Ethernet frame, the format of the Ethernet frame, and then explain the MAC addressing, the layer 2 address in the reference model, and then how the Ethernet use the media to access the media, to share the media between different computers. Okay, and then first about the reference models. As we know, there's different network reference models. Okay, first, this is a TCPIP. Yeah, TCPIP is itself, it's a protocol suite, but it's also the reference models. And another is the well-known OSI reference models. Okay, and other companies, okay, also developed some other protocols, such as the Novell company developed IPX and SPX. Okay, this protocol sometimes, I think about 20 years ago, is used widely in our LAN network. Okay, and IBM also developed a network architecture we called HCNA. Okay, and all these reference models usually is defined as the upper layer protocols. Okay, and the physical layer, the bottom layer is usually use the same. Okay, nowadays the standard for the physical layers, for the bottom layers, there's two types, LANs and the WANs. LAN means the local area network. The WAN means the wide area network. The LANs is a network located to a narrow area, okay, in the campus. Okay, and the wide area usually can extend to a long distance, about some kilometers to thousands of kilometers far away. Okay, and the LAN standard usually is specified by the IEEE. Okay, IEEE. These organizations. Of course, under the IEEE, there's an office we called 802. They specify the many standards about the LANs. Okay, in the WANs, nowadays we usually use Ethernet. Of course, Ethernet is also the LAN standard. And nowadays, Ethernet also has the WAN standard. Okay, and the PPP and the HDLC nowadays are also used for the WAN connections. Okay. Then, first, we refer to the TCPIP reference model. Okay, the TCPIP protocol nowadays is most widely used in our network. And the TCPIP reference model is divided network into four layers. On the upper layer at the top is the application layer. The application layer just the presentation of the applications, such as the pictures, the videos, the voice that interact with the people. Okay, and then the TCPIP protocol. Yeah, it's in the transport layer and the network layer. The transport layer is to confirm the communication between two hosts. Is reliable. That means no packet will be dropped. And if the packet is lost when transmitting, then the transport layer will compensate, will repair it. Okay, this is the transport layer. Of course, the transport layer is the well-known protocol is the TCP. Okay, the TCP. Okay, and then the network layer. The network layer, the protocol is IP. The network layer is to deal with the path selection. That means the communication is between two computers, but between these two computers, there's a network. So the packet should follow certain paths and then reach to the destination. Okay. So the IP layer, the network layer, IP protocol just deal with this. Which path should be chosen? Okay. And then the Ethernet. This is the network interface layer. This network interface layer just how deal with how the IP protocols to use the physical medias. Between each two device, the computer, the host to the router, and the router between router and the two router, and then there's a physical media. Then how to use this media, how to modulate the signals, and then send it to by the physical media to reach the next hop. Okay, this is the function of the network interface layer. Okay, this is the TCPIP layered model. And the most detailed model also is the most widely known reference model is the ISO, the International Standard Organization's OSI model. Okay, the OSI means Open System Interconnection. Okay, that's the model divide the network function into 7 layers, 1, 2, 7, 1, 2, 3, and then the 7. Okay, 7 layers. And this reference model divides the function in between different layers. Okay, first we can see the physical layer. In the physical layer, just the physical device, the lines, the medias, the network interface card, and these hardwares and the connectors and so on. Okay, this is the physical layer. And then the signals sending on the physical layer, it's the bit stream. Okay, bit stream. It's just deal with the signals. Okay, deal with signals, the voltage levels, and so on. Okay, and the second layer is the data link layer. Then data link layer. In the data link layer, there's begin to have the structure of the data. The data have structures. This data we called RAM. And then in this layer, the frame have the address to choose the destination. Okay, and of course also develop a media, how to use the media, developed a mechanism how to use the media. Okay, and then the third level is the network layer. The network layer, in the network layer, the data we called packet. In this layer, just deal with the path selection. Okay, use the addressing and routing. Yeah, just choose the route, the best path to the destination. Okay, then transport layer. The transport layer, the data sending in the transport layer, we call the segment. Okay, segment. And then in this layer, just to confirm the transmission of the data is reliable. That means no packet is lost. Okay, if there's a packet dropped between the two communication devices, then this transport layer will resend the packet. Okay, and then the session layer. The session layer to manage the sessions. Okay, each communication, not only one packet. Okay, there's many packets. This many packet just form the one session. Okay, and then the presentation layer. The presentation layer just to coding just to coding. The coding, encryption or decryption, and the data formatting. That means, for example, what's our people see in the computer? That's a picture, that's a video, but in the computer's storage or the sending of the data, it's not a picture, it's the data. Okay, it's the data. So the picture, usually we know the pictures format such as the JPG, okay, JPG, and such as the BMP, JPG, okay. Okay, that's the format of the data. Okay, this is the function of the presentation layer. Okay, of course, what we see is the picture, and then in the computer, it's the data. Okay, and then the application layer just to show the results. Okay, just to show the results. Okay, and this is the 7 layers, each layer's function. Okay, and of course, the OSI model is most widely known, and there's some relationship between OSI model and the TCPIP model. In the TCPIP model, there are 4 layers. So this 3 layer in the TCPIP model, it's application layer, and then the transport layer, and this is the TCP, and this is IP, the network layer, and then at the bottom 2 layer is the network interface layer. Okay. This is the OSI layered model. Okay, here is the encapsulation of the data. Okay, that means what we see, for example, we processing the data from the 7 layer to the layer 1. Okay, the people just using the data at the 7 layer to see the picture, to see the video, and then this is the data. And then when the data wants to sending to the other side, that's to the another computers, then the data first should be coding to a data that can be sent. Okay, and then in the session layer, for my session, all this layer, the data is the same. Okay, the data, and then the transport layer, yeah, this is the segment. On this 3 upper layer, it's all data. And then on the transport layer to form the segment. Okay, in the segment, the computer will adding a header. This header, of course, have the function that to confirm that no packet. Of course, when the data sending, not only one packet, there's a series of packets, many packets. So you should make sure that no packet is lost. Okay, in the header, there's a serial number and so on. Okay, this is a segment. And then the network layer. The network layer is a packet. We'll choose the best path to the destination. Okay, so the destination should be identified on this header. Okay, that's a network also add a header. And on this network header, there contain the destination's address and the source address and so on. So there's IP address on this header. Okay, and then this packet should be sending to the media. Okay, so the network interface layer, the data link layer, should still adding another header and a trail. The trailer used to frame check, to check if there's some error happened when sending between 2 devices. And this header also to decide the destination, who should receive this frame. Okay, and then the physical layer just change the data into signals, the voltage, the high level or the low level voltage. Okay, this is the encapsulation process. Of course, when the data reaching the receiver, then the receiver gets the signals and then first sending to the second layer. Okay, the second layer first check if the data there are some errors. If there's no errors, then decide who should receive. If it's me, I should receive, then receive it, and then this too is stripped, and then sending to the upper layer. And then using the destination IP address to decide if I should receive, then receive, and then sending to transport layer. Okay, then step by step sending to upper layer, and then show the user, okay, the appearance, for example, the pictures. Okay. On the second layer, okay, the second layer is the data link layer. Okay, in the data link layer, just deal with the data sending from one computer to another directly connected computer. Okay, one device, maybe this is a router, it's the same. Okay, the router is the same, and then one router to another directly connected router. Okay, this is the data link layer's function. Okay, data link layer. Okay, in the data link layer, of course, most widely used is the Ethernet. We focus on Ethernet. In the data link layer, we just adding a header and then adding a trailer. Okay, we have described the trailer is used to check if the data is correct when data is communicating between these two computers, and the header, yeah, contain address that to decide just host B or other host should receive this. Okay, and then we see the detailed contents. Okay, in the previous slide, this is a frame, this is a header, and this is the trailer. Okay, and then trailer is the checksum. Okay, the frame checksum. Okay, frame checksum to verify if this frame is correct when standing between these two computers. And the header, okay, there are two formats. One format is the Ether2. Ether2. Okay, of course, the Ether2 also is the most widely used format in nowadays Ethernet. Okay, the Ether2 is also known as the DIX Ethernet. The DIX, this is the three companies names abbreviation. Okay, D means the backnet, I means the Intel, and the X means the Xerox. Okay, this DIX format. And then in this header contain three fields. One is the destination MAC address, and the second is the source MAC address, and the third is the type. Okay, the destination and the source MAC address means to identify the device. The MAC address is the address, that's the hardware address, we call hardware address. That is bound into the NIC card, that's the network interface card. Each network interface card have a MAC address. So here, when the data is sending from host A to host B, then the source MAC address just the host A, and then the destination MAC address is host B. Okay, then the host B's network interface card bound-in address, okay, MAC address, and then the type. This type field is to identify what data is contained in the upper layer. as we know, in the layer 2, this is the Ethernet link. Then the physical device will know this is the Ethernet network. But what is carried in the Ethernet? As we know in the reference model, Ethernet can carry many different protocols. The IP protocols, the IPX, the Novel's IPX protocols, and the IBM's protocols. Then how to identify this? Just use this type field. Okay, this type field to identify what protocol, what type of data is carried in upper layer. Okay, this is Ether 2. Okay, and then there's another format we called IEEE 802.3. Okay, 802.3. Okay, in this frame, the destination MAC, source MAC is the same, but the stored field is the length. Okay, they are both 2 byte long. Okay, 2 byte long. That's also 2 byte. 2 byte. And then there's the upper layer protocols, upper layer data, and then FCS is the same. But then here lies a problem. Here lies a problem. When the computer receives the frame, then how do this computer to identify if this is an Ether 2 frame or this is a .3 frame, 802.3 frame? How to identify this? So there's a specification. In the specification, the Ethernet specification that says the longest length of the frame should not over okay, this length. Okay, of course, but the upper layer, okay, the upper layer should not over, okay, 1,500. Okay, this we call MTU, maximum transmit unit. Okay, so the field value, if is smaller than this value, okay, smaller than this value, should be the length, because the frame not longer than this value. Okay, and the type value, the Ether 2, when specify the type value, should be bigger than this value, and the value smaller than this will not assign. It's used as the length. So when the data is sending from one host to another host, then the host receives it, then looking into this value. If this value is small, smaller than 1,500, then it's length, and this frame is this format. Okay, so use this format to corresponding to each field. Okay, each field, and then if the value is bigger than this value, 1,536, then this is Ether 2. Then this field will regard as the type. Then we'll know what is the upper layers protocols. Okay, this is the 2 type of Ethernet frame. We should know there are 2 types, and then how to identify each of them. Okay, then first we discuss the Ethernet 2 type. Ethernet 2 type frame. In Ethernet 2 type frame, there's source destination MAC, source MAC. This is 6 byte. MAC address is 6 byte long, and then the source MAC is also 6 byte long, and then 2 byte type. Then the type is used to identify what data is carried in the upper layer data. Okay, and of course the length should be this range. Okay. Then there are two examples. This value 0800. This value means the data carried in upper layer is an IP packet. Okay, it's an IP packet. And this value 0806 means the data carried in the upper layer is an ARP protocol. Okay, and then there's FCS. Okay, FCS. And we can see both these values are bigger than 0600. Okay, it's a bigger value than 1500. Okay, this is the ISO2 frame. Okay, and then there's a IEEE 802.3 frame. Okay, in this frame, the source field, the previous two is the same, and then the source field is the length. Okay, is the length. The length is 2 bytes long, and as we know, this data should not longer than what? Longer than 5,000. Okay, 5,000. Then okay, and then this length value should be smaller than 105,000. Okay, and of course, in the ISO2, we need to carry in different protocols, different upper layer protocols. Okay, so there's a type field in the frame, but now this field is replaced by the length. Then how to deal with the scenario that there's many different protocols, different upper layer protocols. So the IEEE use a sublayer. Okay, this is the layer 2 data link layer, and then this 3 means the MAC sublayer, and then developed ALLC sublayer, another ALLC sublayer, and then use this ALLC sublayer to identify what is the protocol used by the upper layer. That's the DSAP, Destination Service Access Point, and Source Service Access Point, and so on. They are only 1 byte, Okay, but as we know, this system is different from the ISO2. Okay, the ISO2 uses 2 bytes to identify what protocol is carried. So at the end, nowadays in real networks, the ALLC layer is not widely used. So there's another package. Okay, another package. That means we use another format we called SNAP. In this SNAP, the DSAP, SSAP are both AA value. Okay, that means if DSAP and SAP is both AA, then means use the format of SNAP. Then there is followed by the SNAP. And in SNAP, they also inserted a type field. And this type field is compatible with the ISO2. Okay, with the ISO2. Ethernet 2. Okay, and this value can use the type value used in the Ethernet 2 frame. Okay, this is another frame, and nowadays this type IEEE frame is seldom used. Only the protocols developed by IEEE is use this frame, and usually the data we can, if we sniffer in the network, capture the packet in the Ethernet network. Usually, many packets, most of the packets, most of the frame is Ethernet 2 frame. Okay, and then the frame forwarding. Okay, now we have the frame. Okay, then if the host A want to sending the information, sending data to host B, then use the Ethernet frame. And in the Ethernet frame, we know first in the header there are two address, MAC address. Okay, the type figure out what is carried in the upper layer. Then the MAC address, we know it's a burn-in address of the physical address. Each network interface card, okay, in the computer must have an MAC address. And then when the host A sends the data to host B, then should fill in this field. The source should be itself, and then the destination should be the device host A wants to send the data to. In this scenario, it's host B. Okay, then when the data is sending to the media, then all the device connect to this media will hear this data. Okay, then the host receiving this data will decide if this data is sending to me or sending to others. Then it's compared with the MAC address of the NIC card, of the NIC network interface card of itself, and then the address in this frame. If it's the same, then that means the destination of this frame is itself. If it's not the same, then just drop it. Okay, just drop it. Okay, then the MAC address. Then what's the MAC address? The MAC address is a unique address. Is a unique address of the network interface card. Network interface card. Each network interface card have a MAC address, and the MAC address is managed by IEEE. Okay, IEEE. That's each manufacturer, if want to produce the NIC, produce the network interface card, should apply a MAC address from IEEE. Of course, when the IEEE gets the application, then we'll assign a segment of MAC address. Of course, the IEEE use the one segment. Of course, the MAC address, there's 48 bit long. Okay, so the IEEE only specifies the first 24 bit. This 24 bit is assigned to the manufacturer. Okay, this is called OUI. That's the Organization Unique Identifier. Okay, then the manufacturer can use this segment. Of course, there's still another 24 bit. Then this manufacturer can assign a number to each NIC, each network interface card is produced. Okay, this is the MAC address. Okay, address still have different types. In our network, there's a different type of traffic, different type of frame. Okay, of course, the most widely used is the unicast frame. Unicast frame. What means the unicast? Unicast means when the computer sending the frame out, then the destination is only one computer, is only one host. And all the other hosts will not accept this. Okay, that's the one sender, one receive. Okay, one sender and one receiver. Okay, and then in here, in this frame, the destination MAC address, just the MAC address of the host B's NIC, okay, network interface card. And how to identify this? There's a specification said the unicast MAC address, the bit, the eighth bit should be 0. Okay, that means the first number, for example, 4A. Okay, there's 8. Okay, there's 48 bit long. So, okay, this is the OUI, and also there's also other 3 segments. Okay, this is the MAC address. Then in the first segment, this should be an even number. Okay, should be an even number. That means this is 0. Okay, this is a unicast frame. Okay, unicast frame. And another often used frame is the broadcast frame. The broadcast frame means one sender and all the other computers in the network should receive. All receive. Okay, when this is broadcast, then in the frame header, okay, there's a destination MAC, there's source MAC, and there's type. Then the destination MAC, of course, the source MAC still should be the host A who sends the frame, then use whose MAC address. And then destination MAC should not use other one host's MAC address. Okay. Then the MAC address should be use a special MAC address. That's the O1s. FF means O1s. Okay. F means 1111, and another F is 1111. And then 48 bits are O1s. When this destination MAC address is the F, then this frame sending out by host A should be received by all the computers in this network, and then they will receive it and then process it. Okay, this is the broadcast, and then there are still another type, 3 types. Okay, unicast, broadcast, and then the last one, the multicast. Okay, the multicast. Multicast means the computer host A sending out a multicast, then a group of computers, not all, also not one. Okay, only a group of computers should receive this frame. Of course, there are some computers not receive. Okay, but not only one. Okay, there are a group of computers. And in this scenario, the destination MAC address of Ethernet should be a multicast MAC address. Okay, in the destination. Of course, in the source, in this frame, there's a destination MAC and there's source MAC, and then the source MAC still host A send should be the host A's MAC address, and the destination MAC address should be a multicast hub MAC address. The multicast MAC address is defined as the A's bit should be 1s. Yeah, this is the opposite. This is the opposite of the unicast frame. Okay, the unicast said the A's bit should be 0. We can see the A's bit should be 0. This is unicast frame, and the multicast said the A's bit should be 1. Okay, this is multicast, and we can see the broadcast is all 48 bits should be 1s. So broadcast is a special value is included in the multicast MAC address. Okay, yeah, right. Okay, then this is the multicast MAC address. Okay, and then now we have the Ethernet frame format, and we know how to fill in each field. Okay, the destination MAC, the source MAC, and the type. Okay, we know what's the value should be put into this field, and then the data should sending out. Okay, then the data sending from one computer to another computer. Then Ethernet originally, the most early Ethernet is a coaxial cable, and then all the computers are connected to this coaxial cable. That means when one computer sending out the Ethernet frame, all the others will receive it. Then all the others receive it. Then decide who should accept by the destination MAC. Okay. Then there's a problem. If the two computers sending out the data at the same time, then what happened? Okay, this is a collision. Okay, collision, and then these two computers' signals will be interfered. Okay, that means the data will be destroyed, and the receiver, any other computers, cannot listen clearly of each one's signals. Okay, so the collision should be avoided. Okay, should be avoided in the network. So how to avoid? We use the Ethernet use a mechanism we called CSMA and then CD. What means? The MA means multi-access. That means the network media is accessed by many computers, many hosts. Many devices will use the same media. Okay, this multi-access. Then carrier sense. Carrier sense is the mechanism that says when computer C wants to sending out, when the computer C wants to sending out the data to this media, okay, first should listen to the media. If there's any other device is sending, if any other device is sending, then the computer C will hold. That means not send out the data. Until what? Until the computer B is finished. Then the media is idle. Then the computer C can send out the data. Yeah, this is to avoid the collision. Okay, that's a carrier sense. Carrier, that just means the signals in the network media. Then sense means to detect. Okay, detect. And then if these mechanisms, I think these mechanisms can avoid the many collisions in this network, but not all. That means there's some scenario that when this media is idle, then the two computers want to send data at the same time. Because the media is idle, then the two computers sending at the same time. Then when the sending out, of course, these two signals will collide. Okay, will collide. Then the data will destroy. So the carrier sense is not the old mechanism. We also need another mechanism we call collision detect. That means when the media is idle, then the device can send out the signals, but at the same time, this device should detect if there is a collision or not. If there is a collision is happened, then the device should stop sending, and then make the other device know the collision is happened, and then the both devices will hold back, and then waiting a learning time, and then begin to sending again. Of course, carrier sense there. If it's idle, then begin to sending again. Okay, this is the mechanism we called CSMA-CD. Okay, this is the mechanism how the device to use a shared media, Okay, and then the frame processing. That means now the host A, we got the format of the frame. Okay, know each field, how to fill to each field. Okay, and then the data, how to send, how to use the media. Then the device, of course, in this network, maybe there are many devices. Then the device will receive it, okay? Will sense, will get the signals in the network. And then this is the signals. Okay. When the device first receives it, then first we'll use the FCS, frame checksum, to detect if the signals have been destroyed or if it's not correct when sending from source to the destination, if they are then destroyed. And then if it's okay, then to decide if the destination of this Ethernet it's itself or not. That means should use the destination MAC in the Ether frame to compare the destination MAC with the MAC address bound in the NIC of itself. If it's the same, that means this frame is the destination is host B. If it's not the same, then this frame will be dropped. If it's the same, then the frame header and the frame trailer will be stripped. And then the data, of course, it's the IP packet. Then we are forwarding to the layer 3. Yeah, forwarding to layer 3. In the layer 3 protocol stack to process this IP packet. Okay, this is how frame is processing by the host. Okay, and then we go to the end of this chapter. Okay, in the summary, there are two questions. First, how does the Ethernet determine the protocol to which a processed frame should be delivered? That means Ethernet is on layer 2, okay, and the layer 2. And the Ethernet can carry many protocols, such as the IP protocols, and for the Novell, the IPX also can carry on Ethernet. Also, there's IBM's HCNA package and other protocols and so on. Then, if the packet go to the destination, then how do the host knows which protocol should process this data? Okay. Use what? Use the field in the Ether frame. Which field? The destination MAC address and the source MAC address, and then there's a type field. Okay. The type field will tell the computer what is carried, what's the upper layer is carried in this frame. Okay. This use the type field of the Ether frame. Okay. Then the second question: how is it determined whether a frame should be processed or discarded upon being received by the end device? Use what? Use the destination MAC address. Okay. In the frame, there is a destination MAC address, and then the computer receiving this frame. This computer, there's a NIC card, there's a network interface card, okay? Network interface card. That network interface card itself have a bound-in MAC address, okay? Bound-in MAC address, okay? Then we'll compare the destination MAC address and the MAC address bound-in by this NIC. If it's the same, that means the destination of this frame is this computer, and then will be accepted. And if not the same, then we're dropped. Okay, this is the answer of these two questions.